In this video 2.8, we will be looking at proportions in similar figures. You should be able to say I can find missing lengths in similar figures, and I can use similar figures to measure indirectly. Similar figures have the same shape, but not necessarily the same size. In this diagram, triangle ABC, and I'm going to label that here, is similar, so this symbol right here means similar, to triangle DEF. So here's triangle D, E, and F. What is DE? So we want to know this right here, that side. And since they're similar, we can find DE if we have some information. So if I'm saying that, let's say A to B is 4, B to C is 3, and AC is 5. And then on our larger triangle here, I'm going to say that DF is 10. That is plenty of information for us to figure out DE. Since they're similar, which I stated, that means their corresponding sides are in proportion. So 5 on the smaller triangle corresponds to 10. So if 5 is to 10, then we have 4 is to the unknown. So 4 is to, we'll say, X. So once again, if they're similar, their corresponding sides are proportional. So we can set up a proportion. And when we solve this, then I can do cross products, where I do 5 times X is the same as 10 times 4, which is 40. And then we see that it's 8. But you should also see that if we're looking at 5 to 10, we're multiplying that length by 2. So then if you're taking 4, it's 8. But I also wanted to show you that that proportion will work when it's not necessarily such a basic math fact looking at similar figures. A student who is 5.25 feet tall is standing next to a tree. The shadow of the student is 20 feet, and the shadow of the tree is 80 feet. What is the height of the tree? This is a way of finding the height of something indirectly without actually, like in this example, climbing the tree and measuring how tall this tree is. We can imagine there's similar figures being created in this image of two different heights and shadows. So we have the height of the student here, which would be 5.25, and the shadow of the student is 20 feet. So I'm looking at the actual height to the shadow. The actual height of the tree would be X, because that's what we're looking for, the height of the tree, where the shadow is 80. So what I'm doing here, setting up two ratios, I'm going height to shadow when I set it up. And so when I cross multiply to find out the height of the tree indirectly without actually climbing the tree and measuring it, I get 5.25 times 80 is the same as 20 times X. 5 1/4 times 80 gives us 420, which is the same as 20x. Divide by 20 on both sides. So we get X is 21 feet. So the height of that tree is 21 feet. A scale drawing is a drawing that is similar to an actual object or place. Some examples would be floor plans when people are building, like when architects are building structures with blueprints and maps. Maps we see in the car, and we look at a map, or if you look on a on some kind of electronic device like an iPhone and you pull up a map, you see that it's kind of a condensed small image of what we actually drive, the roads, whatever it might be. So floor plans and blueprints are in the planning phases for architects or designers, interior designers, and it's a small drawing of what it's actually going to look like. Now it looks real in a drawing, the floor plans, the blueprints or the maps, they look real because they're made in proportion to whatever it actually is. In a scale drawing, the ratios of any length on the drawing to the actual length is always the same. This ratio is called the scale of the drawing. And a scale model is a three-dimensional model that is similar to a three-dimensional object. One inch represents 12 miles on a map. If the distance between two buildings is 4 inches on the map, what is the actual distance? So if it's 1 inch is to 12 miles, and we have 4 inches, we can set up a proportion to figure out how many miles it is then between the buildings. Notice I have inches on the top, miles matching on the bottom. So a couple things I see here. I can cross multiply. I also see that the bottom is 12 times as big because 1 times 12 is 12, so 4 times 12 would give us x. If you cross multiply, 1 times x, which is just x, equals 12 times 4. If you cross multiply, you're doing 4 times 12 or 12 times 4 to get 48 miles between the two buildings. A model of a new campus building is 5 inches tall. If 1 inch represents 8.5 feet, how tall will the building be? So we've got, let's see, we have this building, and that is, on the model, it's going to be 5 inches. And so we want to know how tall it's actually going to be in feet. And the scale that we're using is 1 inch. I'm putting that on the top because inches is on the top on the left side of my proportion here, is to 8.5 feet. And so I can cross multiply. I also see that the bottom is 8.5 times greater because 1 times 8.5 is 8.5. So I'm doing 5 times 8.5 to figure out how actually tall that building is. Or if I cross multiply, I get 1 times x, which is x, equals 5 times 8.5. And so when we do 8.5 times 5, or 5 times 8.5 to get x, what we're looking for, we get 42.5 feet. So that is how tall the building is. Can you say, I can find missing lengths in similar figures, and I can use similar figures to measure indirectly? Write a summary and reflection and be prepared with any questions for the work time in class.